So thank you to the organizers for having me, and thanks to all of y'all for coming out this morning. I think there's some really nice overlaps between the preceding talk and this one, because what I'm really talking about, despite the title, is really how you can use networks to sort of expand the ability to apply climate science and decision making. So here's an overview. First, I'm going to give you a quick slide about the organization that I'm in part here to represent, that I'm affiliated with at the University of Michigan. And then I'm going to talk about the challenge of scaling up the development of usable information, call it decision-ready information, actionable information, just any time that you have done the work to make climate science immediately applicable for a particular decision in the world. And then I'm going to go over two solutions that we worked on at GLISA, the organization that I'm affiliated with. The first one you can think of as being at the organizational level, so it's what GLISA has done itself. And then the other is sort of looking more broadly at what the Great Lakes region, the United States and Canada have been doing. So first, some background about the Great Lakes Integrated Sciences and Assessment Center. It is one of NOAA's 11 regional integrated sciences and assessment centers. They are climate service organizations spread out throughout the United States. They do outreach, climate science, and social science, all under one umbrella in one building. They provide information for adaptation to the regions that they serve. The Western Water Assessment that was in the last presentation is another one. The Great Lakes Integrated Sciences Assessment Center services the 8 Great Lakes of the United States that surround the Great Lakes and the province of Ontario. And GLISA was actually pretty late on the scene, both in terms of being a regional center in general and especially to the Great Lakes region itself. It was established in 2009, 2 decades into there already being work done around climate change in the Great Lakes region. And for that reason, when GLISA was started, it needed to sort of immediately be able to integrate itself into the region and sort of scale up its ability to integrate itself in. So I consider this part of the larger challenge of scaling up the development of usable information. So, and again, decision-ready, actionable science, whatever you want to call it. The literature on climate and decision-making shows that climate data can be integrated into decision-making successfully. Interactions between producers of climate science and potential users can be a really critical component of that process. Interactions build trust, they translate terms, clarify misunderstandings between both producers and potential users of climate science, and they identify potential opportunities for overlap. However, this model decision support based on direct interactions is very costly. It's highly resource intensive, especially human resource intensive, and there's a fundamental mismatch between the size of the climate science producer or broker communities and the potential user communities. We only have but so many scientists that only have but so much time to do outreach work. And there's almost a potentially unlimited user community out there, and it's almost infinitely diverse. It goes from farmers to cities and everywhere in between. So there's a pressing need to find ways to scale up both organizational outreach capacity and the ability to generate usable information for decisions. So the first solution that we've been working on is something that we call boundary chains. And this was mainly the idea of my advisor, Professor Maria Lemos, and I'll have the title of the paper at the end of the talk. But just roughly real quick, boundary organizations are groups that specifically are tasked with sort of living somewhere in between the producer community of science and the user communities of science. And you know, they're both supposed to connect the two communities and also protect the process of moving science into decision making. Make sure science isn't corrupted by policy and policy isn't improperly influenced by science. So what we call boundary chains are really just adaptive collaborations between multiple boundary organizations across whatever boundary that they're tasked with bridging. And it might sound obvious to have partnerships between these kind of organizations, but this really hadn't been described in the literature yet before this paper came out. And the main goal is to reduce the transaction costs involved with sharing resources and leveraging the existing trust that existing boundary organizations have. So again, GLISA started really late in the Great Lakes region around 2009, and there had been a lot of groups that already had existing relationships throughout the region that GLISA really wanted to piggyback on and sort of use their connections and use the long-standing relationships that they had already had to get more leverage on our own work. So these kind of partnerships have allowed for a high level of customization of climate information and outreach work around climate science without sacrificing the diversity of the kind of groups that GLISA has been able to serve. So I'm going to roughly run through 3 forms of boundary chains that are described in the paper. The first is something that we call the Keychain. And this is because Professor Lemos has a very complicated keychain of her own that she uses everywhere and is constantly jingling around. The main idea behind this one was for us to be able to broaden diversity at any time that we're working. So what we did is we took some of the funding that we get from NOAA and we had an annual grants competition. And the idea was to have organizations throughout the region apply to us to say, hey, we want to do outreach work around climate change, can you help us? We give them some funding for a year, and we also make sure that we're providing some of our great climate scientists that we have on staff, like BJ Bally, who's here in the front row, to actually interact directly with them and make sure that they're getting the support that they need to do that. And so we'll run through about 4 or 5 of these projects a year, all at the same time, and just, try to service different kinds of potential communities of users at the end of that chain. But sometimes the ability to reach the ultimate decision makers, the ultimate users of information, it takes another link in the chain. It takes even more customization. And the example I put up here, we call these link chains that allows us to deepen this customization. We sort of have multiple, even more boundary chains, even more boundary organizations that we're connecting with. So the example that I just threw up here from one of our projects was, we wanted to be able to do outreach work to tribal groups or First Nations communities throughout the United States and Canada. But that's a very specialized communities to work with. There's a lot of specific information, a lot of rich history that you have to understand about their experiences, especially with working with federal governments. And so the first boundary organization that GLISA connected with there is the College of Menominee Nations, who sort of had that general understanding about how to work with tribal groups or First Nations groups. And but then to actually do the immediate outreach with any one particular tribal council, they would be connecting with a particular committee that advises that council. So, certain tribes might have a sustainability council or an environmental council or something like that. So you have sort of multiple iterations of partners that you have to work with in order to actually finally be able to gain the trust and have the direct conversations with the final information user, which in this case would be like a tribal council that makes the actual decisions. So finally, we have this crazy idea about a network chain, and the idea here is really thinking broadly about developing the larger capacity at an almost regional level. And so the idea here is really sort of training the trainer. So over years, we developed deeper and deeper relationships with some of those that we're partnering with, and they eventually become able to do some of the outreach work around climate change themselves and influence others that they work with. So ideally, we can almost do sort of a handoff over time, with some level of management. And that obviously brings up complicated issues about handing off this kind of work. Will they misuse the science? Will they sort of misunderstand it at certain points? And will that propagate? And for that reason, we started thinking more broadly about how larger scale systems can manage the development of usable information. And we started really thinking, okay, we really need to look at this as a regional issue and think about how organizations across the region connect to one another and can do this. So we were looking at again, across the whole Great Lakes region, developing and sharing usable information, and we decided to focus in on a particular issue, and for us that was water quality in the Great Lakes. Water quality was a good topic for us because it's one that has been a particular focus of regional networking, and climate change has recently become a focus aspect of it. So first we created a view of the overall regional climate policy network. We collected 42 science policy documents around climate change, similar to the kind of assessments you were looking at earlier. We interviewed 20 individuals who work for influential organizations around water quality in the region to really sort of follow through their decision-making process. How did you first come to understand climate change? Do you integrate it in your work? Were you involved in this network, and how did it influence you? Those kind of things. We developed a conceptual model, which I'll present in my last slide. So we mapped and did ANOVA tests that imply that those working regionally collectively pursue work of similar relevance to dispersed specialized groups, which are then more isolated. And I hope that'll be a little more clear when I actually show you the map on the next slide. Our interviews with practitioners also describe that they experience a meaningful distinction and sought different resources from different scales of their professional network. So again, we're similar to the previous talk, we're now talking about, okay, how do people leverage their networks on different scales? So the regional network that was occurring across the whole region was really building awareness and lending credibility to the issue of climate change. And then people would go back and turn to their own professional networks that they were used to working with and create more specialized networks that would allow them to tailor that broader conversation into their own working environment, help them craft what the meaning of climate change would really be for their work. So just real quickly, the dots, you probably cannot see them, are colored based on sort of what the scale of focus that someone had in their work. And that was generated from just looking at their CVs. And what you need to take away from this is basically that there was a concentration of people who work at the regional scale in the center, and everything around them tended to draw more from local scales. So just real quick, we connected this to the literature on communities of practice, which is very rich and covers a lot of different fields. Learning experiences that emerge in collaborations around solving reoccurring issues that are held in common. The key thing to take away here is there's an iterative, productive tension between general discussions and applied experiences. There's a difference between theory and practice. We can talk at the regional scale broadly about what climate change might mean, but then you go back in your applied context and you see, well, it wasn't exactly what I experienced when I really worked on it. And the idea, roughly in this conceptual model, hopefully we'll have a paper coming out on this year that you can read and get more details on this, or just talk to me afterwards. The idea is basically that you can have feedback loops forming between these specialized networks, these communities of practice, that can end up feeding back into the regional network and growing the larger region's capacity to understand how to make climate science applicable for decisions that are taking place throughout the region. All right, thank you. Haven't gone red yet. Okay, that's fine, thanks.